Click the bell icon to get latest videos from Ekeeda.
Hello friends, here we are coming for the solving complete design of CE amplifier of BJT amplifier. In this design, we have to form all the values of resistances, capacitances based on customer requirement. Let's see what customer wants. Question is, design RC coupled CE amplifier to meet following requirements. So customer want the gain is greater than 90. Stability factor should be less than 8. That means circuit should be highly stable. Your low cutoff frequency is given 20 Hz. Below that, I won't use this circuit as an amplifier. Calculate voltage gain, input impedance and output impedance with designed parameters. So this is the second finding after this complete design. We will follow the steps, and for that you just refer the previous video, design steps of BJT CE amplifier. For design, we will use step number 1, that is selection of the transistor. We will say that as AV is greater than or equal to 90, we use BC547A transistor with following specification. That specifications are, for BC547A, the specification HFE DC typical value, that is 180, HFE AC typical value, that is 220, the value of HIE is equal to 2.7 kilo ohm, VCE SAT, that is equal to 0.25 volts. That's it. Now here one more thing is given. If few specifications, few requirements are not given, we have liberty to choose to assume the particular value. Now here in this case, VCC is not given and VO as well not given. So what we'll have to use, we have to assume the value of VCC and then proceed further according to that particular value of VCC. After selection of the transistor, we'll go for step number 2. That is nothing but calculation of RC. I know the value of HFE DC typical and HFE AC typical. Now question arises whether I have to use HFE DC typical and when I have to use AC and when I have to use DC value of HFE. For AC analysis specification, for example, in a gain formula, you have to use AC HFE. For stability factor formula, you have to use HFE DC value. Clear? So, calculation of RC. In this case, we will use AV is equal to minus HFE divided by HIE into RC. Here in this case, take HFE is equal to HFE AC typical, and that is equal to 220. HIE is always constant, that is 2.7 kilo ohm. AV that is given, they have mentioned that it is 90. Least value is 90, not less than 90. So we'll take worst situation. 90 is equal to, obviously it will be minus 90 because CE amplifier we are using, so it will give phase shift of 180 degree, results in negative sign in your voltage gain formula. Minus HFE is equal to 220 divide by 2.7 kilo, which gives you the value of RC. And the value of RC, just calculate, take a pause of 1 minute and calculate the value of RC. 1.1 kilo ohm, that's the value of RC. But I have to take on the higher side, because if we take the value of RC is equal to 1.1 kilo ohm, I'll get exact value of 90, and with the voltage and environmental parameters I can get the value of AV, which is less than 90, just below 90. So to enhance the value of voltage gain, we will use the RC at the higher side. So RC standard, I will take it on 1.2 kilo ohm, but not more than 2 kilo ohm directly, just near to it but at the higher side. In this way we have completed step number 2 for calculation of RC. Step number 3 is calculation of Q point. Now here you have liberty to choose A type or B type, because VCC is not given, and more than that VO as well not given. So we'll say that assume VCC is equal to 20 volts. If you assume that VCC is equal to 20 volts, VCEQ is equal to VCC divided by 2, that is 10 volts. So VRE is equal to 10% of VCC, that comes out to be 2 volts. Applying KCL, we will be getting the value of IC, which is equal to VCC minus VCEQ minus VRE divided by the value of RC standard that we have used. So value of IC is coming out to be 6.66 milliampere. Once we get the value of IC and we get the value of VCEQ, we can get that Q point is coming out to be 10 volts, 6.66 milliampere. If you want, you can show that in graphical manner, that is in this way. This is your VCEQ, that is 10 volts, and here you can draw the VCC. Here you will be having the value of IC and VCE, and here it is your Q point, which gives you the value in the form of VCEQ, ICQ, which is equal to 10 volts, 6.66 milliampere. Very straightforward. Step number 3 is completed. Step number 4. In step number 4, we just have to calculation of RE. I know that what is VRE? VRE is nothing but IC multiplied by RE. RE will become VRE is 2 volts and this IC is coming out to be 6.66 milliampere. So calculate the values. 2 divided by 6.66. This is coming out to be 300 ohm. You can keep this value as it is, or else you can take it on the lower side. RE standard is equal to 300 ohm with 0.25 watt. Calculation of RE is completed. Now in step number 5, we have to proceed further for calculation of R1 and R2. I know that stability factor S is given as 8. which is given parameter from the customer requirement, then I can say 8 is equal to 1 plus RTH upon RE. You can say that 7 is equal to RTH upon RE. You can get the value of RTH very easily. 7 multiplied by RE, that comes out to be 2.1 kilo ohm. So RTH is equal to 2.1 kilo ohm. Fine. And we can also have RTH is equal to the value of VTH divided by VCC multiplied by R1. What's the value of VTH? Is equal to VBE plus VRE, and this is 0.7 volts plus what is VRE? VRE is equal to 2 volts. 2.7 volts is nothing but the value of VTH, and VCC is known to us, RTH is known to us. We can easily calculate the value of R1. R1 coming out to be 15.55 kilo ohm. We'll use R1 at the higher side. So R1 standard will become, I can take 17 kilo ohm slash 0.25 watt. Simple calculation. And from R1 parallel R2 combination, I know that R1 parallel R2 is equal to RTH. So R2 will become, you can easily get the value of this R2 very easily. That is nothing but how to use the calci very quickly. RTH inverse minus R1 inverse, the whole inverse. This will give you the value of R2. 2.39. So I'll take the lower side value of R2. R2 standard is equal to 2.2 kilo ohm. Is it fine? No problem. So 2.2 kilo ohm, 0.25 watt. This is the value of R2. So we have completed calculation of all the resistances. Only capacitances calculation is left. Step number 6 is calculation of all the capacitances. CC1. For CC1, I'll just draw this circuit over here. This is your R pi, and that is nothing but your HIE, which is 2.7 kilo ohm. This is the value of RB for the standard values, and here the value of CC1. No source resistance is given, so simple calculation, CC1 is equal to 1 upon 2 pi R into FL, where FL is given, so we'll write it over here. FL is equal to 20 Hertz, which is given in your customer requirement. 2 pi R is equal to RB parallel R pi. In RB, one is 2.2 kilo and another is 17 kilo. One is 2.2 kilo and another is 17 kilo. So RB is coming out to be 1.95 kilo. That is in parallel with 2.7 kilo ohm. Their parallel combination coming out to be 1.132 kilo ohm. And CC1 will become 7.02 microfarad. We will take all the capacitors towards the higher side, and this is how we will be getting CC1 standard 10 microfarad with 1.5 multiplied by 20, that is 30 volts. So the capacity of this capacitor CC1 is 10 microfarad by 30 volts. Calculate for CC2 similarly. I'll just give the values. This is the value of RC we have got. This is the value of CC2. Only one capacitor, one resistor. Simple. Here I will write it as RC and FL. RC that we have got as 1.2 kilo ohm. This value is coming out as 6.6 microfarad. Again, this I will take it on the higher side. So CC2 I will take on 10 microfarad. You can take 6.8 microfarad as well. So 10 microfarad by 30 volts. This is the second capacitor, and the last calculation in your design is CE. So CE will be getting as 1 upon 2 pi R E dash multiplied by FL. We have to calculate the value of RE dash as this is your value of RB, this is your value of R pi, and that is nothing but HIE, which is equal to 2.7 kilo ohm. This is your value of RE. Capacitor CE that we have to design. First of all, calculate the value of RE dash, right? The value of RE dash is coming out to be RB parallel R pi divided by beta plus 1 in parallel with capital RE. Okay, RB parallel R pi is coming out to be 1.13 kilo ohm divided by 101. Is it? No. In this case, we don't have to consider beta is equal to 100. Beta means beta is equal to HFE AC typical. We don't have to consider. HFE AC typical is 220, and that is why your value will become RE dash is equal to 1.13 kilo divided by 221 in parallel with the resistor, that is RE, which is 300 ohm. The whole calculation is coming out to be having very less value of resistance, that is 5.05 ohm. And this is how we will be getting the value of CE is equal to 1 upon 2 pi R is 5.05 and this is 20. CE value is coming out to be 1575 microfarad. It's very high value of CE that we are getting over here. I will treat it towards the higher side. CE is equal to 1600 microfarad with 30 volts. This is your CE standard value. This is how we have completed your design. Now next step is draw the complete circuit with designed parameters. this is 20 volts plus VCC. R1 is 17 kilo ohm. This is 2.2 kilo ohm. RE is coming out to be 300 ohm. This is 1600 microfarad, which is a very high value. This is 10 microfarad. This is 10 microfarad. And this is 1.2 kilo ohm. We are using BC547A as a transistor part. All the design parameter is completed, and now go for the last calculation, that is voltage gain, input impedance and output impedance with respect to your designed parameter. We'll draw AC equivalent circuit, then we'll get to know that what will be your input impedance, output impedance and voltage gain. Your input impedance is Ri is equal to Rb parallel HIE. What is your value of IB parallel HIE? We have already calculated 1.13 kilo ohm. So Ri input impedance is 1.13 kilo ohm. Output impedance is nothing but Ro is equal to Rc, which is equal to 1.2 kilo ohm. And voltage gain is equal to minus HFE upon HIE multiplied by RC. HFE is equal to 220, HIE is equal to 2.7 kilo ohm, and this RC is 1.2 kilo ohm. This is coming out to be 97.77 with negative sign. And this is the typically value of voltage gain which is under the customer requirement, which is well above the value of 90 which is given by the customer specifications. So this is how we have completed the 15 marks question, that is design of CE amplifier with BJT circuit. Thank you so much for watching this particular video. I hope you like this video. If you like this video, like, share and subscribe Ekeeda channel. Thank you so much.